All right, so today we're going to talk about relations and domain and range. So first, when you have a relation, it's a set of ordered pairs. So an example of an ordered pair would be like 0, 2. Maybe we have the point 2, 6. So there's lots of ways we can represent these. So the first form you can have is a table. So if I put in 2 into my function, 6 comes out. I put in 3, 11, 4, 18, 5, 27. So what mapping would look like is I would say 5 maps to 27, 4 maps to 18, 3 maps to 11, and 2 maps to 6. Graphing it, I would graph over wherever the dots were. So I don't really have these on here, so I can just graph random dots on here. So that's what it would look like for a graph. And then the equation I have that should match these answers if I did my math right. The equation can also represent in relationship. So when we talk about domains, we talk about the set of all input values. And typically we call those the x values. All right, so anything that goes into the equation, that's called, and then this is all, it's the set really, the set of all output values. And typically we call these the y values when we're doing these. So some examples down here. I want you to give the domain and range of each. So the domain are just your x values here. So I'm going to say it's a set of -1, 7, 3, and -5. And then the range is going to be all these y values. So it's a -1, 4, 0, and -1. So technically, you only have to write the -1 one time since it's right there. If you write it twice, I'm not going to take off for you. But technically, since it's already there, you wouldn't write it twice. So right here, you'd actually need to like label these ordered pairs. So this would be like 2, 0. This is 1, 2, and so on. And so once you have labeled all of these ports here, this is 1, -3, and so on. So then I would just label all the x values here. So that would be a -3, a -1, 1, and 2. And then range, I'd label all my y values. That's -4, -3, 0, 2, and 5. So same thing here. These are all the x values. So that's what we typically call our domain. So you would write down all those values in this spot. And then the range would be 0, 1, and 4. So now when we look at graphs, it gets a little bit different. So when we're doing the domain, you're looking left to right to see what value is working. And so these down here, I don't know if you can tell, those are arrows, which means that this pattern is going to continue forever. So all of our numbers for the x's will eventually get hit. So we say that this is, -infinity to infinity is your domain. And then our range, the highest it goes up to right here is 6, and then it's everything below it. So there's lots of ways you can write your range. I typically would write that -infinity up to 6 with a bracket. You could also say that it is the set of all y values such that y is less than or equal to 6. And then you could just do interval notation, which is just this part here where you'd say y is less than or equal to 6. And this is typically what we would do in like Algebra 1. This right here is more of the proper notation that you would use in higher level math. So this one right here, our x's start at -3. So then we would say it starts at -3 and it runs us up to infinity. And then my y values down here start at -4 and goes up. So we start at -4 and then we get to infinity for that one. The domain is also the same thing as saying that x is greater than or equal to -3 and the range is y is greater than or equal to -4. But typically we write it in interval notation. So the domain right here, it has all the values except right here at 3. So the way we write that would be -infinity to 3 and then 3 to infinity. So if you've noticed here, I've used parentheses on this one and brackets on these. So this means that the number actually worked. So it's filled in dot, we use this. This is that it will never hit 3. So that's why we put parentheses around it. And then the range right here looks like there's an asymptote probably at 0. So we'd say -infinity to 0 and 0 to infinity for this one. All right. So on the rest of these back here, since this goes in every direction, we'd say -infinity to infinity. The range looks like it runs from -5 up to 5. This one right here, your domain is everything except for that open dot. So -infinity to -1. and -1 to infinity. The range is everything except for the dot again, which is at -3. So this right here, I have all my x values in this direction right there. So it's everything up to 0. So we'd say -infinity, 0. I put a bracket because there's an actual dot right there. Range, it looks like the range is going in both directions. So this would say -infinity to infinity for that one. So down here, the x values, if you can tell right here is the line for it. The x's are going in each direction, and the y, since it looks like it's going down and it's approaching the -5 line, because this looks like an exponential function to me, I'd say it's -5 to infinity. You'd have to be sure though, because this picture here looks like it hits it. So I'm pretty sure this is supposed to be an exponential function that has an asymptote at -5. This one right here looks like there's an asymptote right here. So we would say -infinity to -1, and then -1 to infinity. And then the arrows for the y's go in both directions, so we say -infinity to infinity. Now this one right here, my x's, that one's open dot, so I'm going to use a parenthesis at the -4. That one's closed, so it goes up there. The y's run this direction, so from here to here, and all of them. So you don't have to consider this one for the y because it's filled in over here, so you don't have to exclude it. So we would say -7 to 2 funds that. Okay. So we say a function is a special type of relationship in which each element of the domain is paired with exactly one of the range. So that means that you can't have 1x going to 2y's. So this is right here. So what we're saying is that negative, so none of these repeat. So you're asking, do the x's repeat? And then the answer is no. So this is a function. Here, this x goes to 2y's. So this is not a function. And then here, just check your x's. Your x's do not repeat, so you say yes. Now, if you're looking at a graph to tell if it's a function or not, remember you're going to have the vertical line test. So you're drawing imaginary vertical lines and make sure it doesn't hit twice. So this one is a function. This one right here, it hits twice on my vertical line. So this one would not be a function. And this one, if you draw a whole bunch of vertical lines all over the place, this one does not hit twice, so we would call it a function.